Today we're still on the problems series that we've been doing on building a midship on my stability playlist. So we're still on our basic ship. It's 100 by 12 ship with a draft of 6 meters and with an Amidships commitment of 6 by of 10 by 8, looking at it from the top view. So if you haven't watched my stability series, please just start from the beginning because it's an ongoing series. It's very informative. So okay, please subscribe and share, comment if you find any errors or just to appreciate the work that I'm doing. So let's tackle the problem on screen as usual. Okay, I just mentioned all the dimensions from my ship. Now let's look at the problem. An Amidships compartment has a watertight of 6.5 meters above the keel. Find the new draft if the compartment is built. Okay, so what they literally saying, they're saying they have a water compartment that is about 0.5 above the keel. Okay, remember our draft is 6 meters, and now they're saying that on that midship compartment it is bilged. There is a hole, so now water is flooding inside the ship. So if water is flooding inside the ship, what is going to happen next? We're going to lose buoyancy, force that keep us floating. So if we lose a force that keep us floating, what next? We are going to sink. So we're just going to read another new draft, okay, because we just sank. Okay, so the question is, are we going to sink till we reach our watertight flat compartment, which is 6.5 meters above the keel? So are we going to read a draft of what, or should I say a new draft of what, of 6.5 meters above the keel? So to get to know that, we are just going to take use of our indigenous formula that we've been using. If you follow the channel, you should know that we've been using this formula. Volume of lost buoyancy is equal to sinkage is equal to volume of lost buoyancy all over what? All over intact water plane area. Okay, so if I will try to cross multiply here, I'm just going to land in a formula that say sinkage into intact water plane area is equal to volume of lost buoyancy. Okay, so we now know the formula for volume of lost buoyancy, of which is sinkage by intact water plane area. Okay, so we also know that to keep sinking, if we lose something, we need to gain it, because we wanna keep sinking, right? We wanna keep floating, so we need to conserve the buoyancy. By conserving the buoyancy, we mean to say we need to gain volume of gained buoyancy should be equal to volume of lost buoyancy. I mean to say, after and before bilging, we need to have very same buoyancy, because we haven't changed anything on our mass. Remember, buoyancy balance the mass of the ship. Okay, since we haven't done anything like jettison the cargo or like putting off the cargo, like putting it overboard, like taking it out of the ship, so we haven't done any of those, meaning our mass is still constant. Then also only our buoyancy we just lost. So we need to gain very same buoyancy as we lost. That means we're conserving what? Our buoyancy. Okay, what is our next step? We know that we need to to conserve buoyancy. So we know that volume of lost buoyancy is equal to L times B times D. This one, length of the compartment, breadth of the compartment, and what? And draft of our ship. Okay, that is the buoyancy that we just lost. So we have lost 10 by 8 by 6 for the draft. That how much points we've lost. If we work that on a calculator, we get a number of 480 meter cube. That is how much points we have lost. So the question is how much. Okay, the question that we had was, are we going to sink till we reach the water flat compartment? To get that, we're just going to find our sinkage to reach that. For us to read a draft of 6.5, that means we have sinked what? To get sinkage, it's going to be equal to height of water flat compartment minus draft. So if I do that, I'm just going to have 6.5 for a watertight flat above the keel minus our initial draft. Our initial draft was 6. So for us to sink till we reach the water flat, watertight flat, then we'll have sank about 0.5 meters, half a meter. Okay, the question is, are we going to sink that much? Okay, so okay, now let's find the volume. We just did volume of lost buoyancy. Let's try to find volume of gained buoyancy. Okay, so volume of gained buoyancy is sinkage by sinkage. We're still going to use the very same formula, because volume of gained buoyancy should be equal to volume of lost buoyancy. That's why we're still using that one. Intact water plane area. So now our sinkage, are we going to sink 0.5? Let's put 0.5 as our sinkage. Intact water plane area, we're still going to use length times breadth of the whole ship, of which is 120, 1200, subtracting the area of the amidship compartment. It's 10 by 8, making it to be 80. Then we get volume of gain points. If you put this in your calculator, then we have gained, if we sink 0.5, we would have gained a buoyancy of volume of 560 meter cube. Something that we can notice by now, that we just gained more than we just lost, of which is impossible. If that was the case, our ship would have just risen up, okay, instead of sinking. Okay, so that is not a case. We can't gain more than what we just lost. So that means we didn't sink 0.5. We need to find our sinkage. Our sinkage, go back to our formula that says sinkage is equal to volume of lost buoyancy all over intact water plane area. So then volume of lost buoyancy, dimensions, we don't change, it's 480 all over intact water plane area. Intact water plane area is what? Then we put it up, it's going to be 1200 from here minus, you can either work it out again. So if you put that on a calculator, on your calculator, you could end up with an answer of 0.429 meters. So literally we're going to, if the ship is built here, we're going to sink about 0.429. that is less than 0.5, which is the water flat is. So we're not going to sink till we reach it, so we're just going to be slightly close to it. So to get our new draft is going to be initial draft, of which was 6, plus what? The sinkage. Our sinkage is 0.429. Then if you work that out on your calculator, you're going to have your new final draft of 6.429. So we are not going to sink till our watertight. We are going to sink close enough to it.